Hey guys, welcome back. Before you take this, watch this video and take this pass off, please make sure you've done your anatomy quiz first, okay? If not, go back, repeat that. I've reset all of those pass offs to only take your highest score. So by going back and failing, maybe having a lower score than you initially got at some point, it won't lower your grade. So go back, review those pass offs to make sure you can get as good a score as possible on your quizzes. You have 2 attempts right now. You will get 1 more if I see that your Quizlet has been completed. That quiz is not due until next Friday. So if it takes you, if you want to make sure you go back and do some good reviews before you take another attempt at that quiz, that's a-okay. All right, perfect. Moving on to standard 6. Standard 6 is really simple. It's just identifying where gas exchange occurs in the lungs, and which is the alveoli. So know that. Now, the important thing about that is not just where the site is, but how it occurs. And so gas exchange of the alveoli happens completely due to diffusion. And if you remember diffusion, that's the idea that there's a lot of oxygen over here and not so much oxygen in this area. So oxygen will go from an area of high concentration to low concentration, and vice versa. If there's a lot of CO2 over here and not a lot over here, this CO2 will go right over here. And it's just the idea that everything's trying to move to an area that it's equally expanded over. Um, and that's what happens in your lungs. You breathe in air that's higher in oxygen than your oxygen depleted blood, and oxygen will go from the high concentration in the alveoli to the low concentration in the capillaries. And then the exact opposite for CO2. CO2 is in high concentration in your blood and will go to the low concentration inside of your alveoli. And then, so as you just bring in fresh air that's higher in oxygen, low in CO2, this diffusion will take place, and then you can breathe out air that is now lower in oxygen and higher in CO2. And this is the kind of picture that will help you understand. This is showing what's called partial pressures of these gases in air. And so this is showing you that air, when you breathe it in, has almost no CO2 in it and a whole lot of oxygen. And so the pressure for oxygen in these capillaries to go into your blood when it gets oxygenated is extremely high. And so the only problem is because diffusion just reaches a midpoint and then it's stagnant, you can only get so much oxygen into your blood at a given time. This is why you can hold your breath and still maintain enough oxygen in your body, because there's a whole lot of oxygen in the air that we breathe in. So you go from this is what's in depleted blood, this is what's in the air. And so you can see the midpoint for the red, which is oxygen, is exactly in the middle between that point and that point. And the same thing for CO2. If it goes from being over 50% and in regular air it's like less than 1%, significantly less than 1%, then you're going to end up with something here around, I don't know, 25, 26, 30, somewhere in there. Okay. Okay. So that's just showing you that it's diffusion. You're never going to get 100% of your internal oxygen and CO2 to match the air. We don't have, that's the downfall of our respiratory system, is we don't have the ability to squeeze all of that oxygen out into the air. If you want to find a creature that can, below this I'm going to link a video to birds' respiratory system, and also fishes have a good one too. But bird respiratory systems are terrestrial creature who breathe the same air as us, but they squeeze a lot more oxygen out of it. So if you're bored, which you might be, check out that video right below this. It won't be on any quizzes, but it's a good FYI. All right.